good morning to all of you. In the previous classes, we have discussed about compound macroscope and simple macroscope and their magnifying power we have discussed, and we have also discussed about astronomical telescope lastly. So today we have arrived to the last class of this particular topic, chapter ray optics, and your last topics of today will be reflecting type of telescope. As we have discussed refracting types of telescope, and today we are going to discuss as a last topic, that is refracting types of telescope. You please note down, we'll use today about reflecting types of telescope. Reflecting types of telescope. Okay, refracting types of telescope, you please note down. Refracting types of telescope, and here we'll discuss about first Newtonian telescope. Newtonian telescope, and secondly Cassegranian telescope. About these two topics we're going to discuss. As we found it about the definitions of telescope, that we used to see a distant object nearby us in a distinct way, or clearly we want to see a distant object nearby us. Okay, so let's go for the first, that is a Newtonian telescope. Newtonian telescope. You can write a headline, that is as Newtonian telescope. Newtonian telescope. In this telescope, what we will use, that in case of refracting types of telescope we used lenses, but since it is reflecting type of telescope, so we are going to use here mirror. And in case of Newtonian telescope, we will use first of all a concave mirror of large focal length and large aperture. So first of all we'll use a concave mirror which has large focal length, as well as it is a concave mirror of large focal length and large aperture. Am I clear? So why we use large focal length, large aperture concave mirror? If we use a concave mirror of large focal length and large aperture, the gathering power of light will be more, and the resolution power will also be more. Then the image will be bright. That is the reason why we use a concave mirror of large focal length and large aperture. So here we go for the next step, that is the principal axis, as you all know. And suppose the object is at infinite distance, that means the ray of light will start coming like that. After reflection, it is going to pass like that. After reflection, it will be passing in this way. Similarly, this is another ray that is coming parallel to principal axis, and after reflection, this is going to be reflect like that. Say this is focal length, and this is point is F, and ray is coming this way. Okay, these are the directions. Object is at infinite distance. So image is forming here. What we do in case of Newtonian telescope is that apart from using this concave mirror of large focal length and large aperture, we use a plane mirror here so that it get placed at an angle of 45 degree. So this is the plane mirror which have been placed at an angle of 45 degree. Then what will happen? Then this after placing this plane mirror at a 45 degree angle, then this point will behave as partial object for this plane mirror, and finally the image will be forming somewhere here. Image is forming somewhere here in this point, and this is going to be the image as you can see from here, and this is the image. And when the observer will see by the help of the eyepiece, so this will be like that, and this is the observer. Is that clear? What we used first, we used a concave mirror of large focal length and large aperture. What is the benefit of using it? The gathering power of light is more, and the resolution power is also more. Hence the image will be bright, because it can collect more. If the aperture is large, then it can collect more and more light of rays. Okay, ray of light. So finally, this is normal procedures, and this is the point where images were produced. And then we keep an plane mirror at an angle of 45 degree. Then this point will behave as partial object. Hence, this mirror will project the image at this point, and by the help of an eyepiece, the observer will able to see the image. No derivation is required for Newtonian telescope. So this is the plane mirror, as you can write. This is plane mirror that is placed at an angle of 45 degree. Correct? So this is all about Newtonian telescope. Next is, you can note it down, or you can draw this diagram. Next is Cassegranian telescope. Okay. Next is Cassegranian telescope. Cassegranian telescope is also one type of reflecting type telescope. So here also we'll use the mirror. This is Cassegranian telescope. And Cassegranian telescope will have also an reflecting types of telescope. So here also we're going to use mirror. What mirror we're going to use in this case? We are going to use here again a concave mirror, but this concave mirror will be slightly different in comparison to the concave mirror we use in case of Newtonian telescope. Okay, that this is a concave mirror of parabolical size, parabolical size. What is this parabolical size is concerned for? Parabolical size mirror used to have a hole at the middle point. That means in the middle portions there is a hole if the mirror is a parabolical size. You remember this point. In case of a parabolical size concave mirror, there is a hole in between the aperture. So if you see this mirror from this angle, you will see a hole here. So this is the specialty of a parabolical size concave mirror, as you can see in this particular point. And then this will be your principal axis. As usually, the beam of light will start coming like that, and after being reflected, it is going to passes through the principal focus. It is going to passes through the principal focus, Similarly, this is also one ray that is also going to passes through the principal focus after being reflected. That's fine. So these are the direction. Okay, these are the direction, and this is the point where the image is formed. In case of Newtonian telescope, we used here an plane mirror, but here we'll use not plane mirror, but here we'll use a convex mirror. What we use? We'll use a convex mirror. So this is a convex mirror. This is a convex mirror, and this convex mirror will behave as secondary mirror. Okay, so the final image is going to produce like that. Image is going to produce, as you can see here. Okay, in a diagram. If I join this line, then it will be very easy to understand you. Okay, so these are the direction. Clear? This is the coming from infinity, again coming from infinity. Once you keep this mirror here, so they're going like that, and finally this object image will be seen by observer by the help of an eyepiece. By the help of an eyepiece, and here will be the observer. So this is Cassegranian telescope. What we use in case of Cassegranian telescope, we use a concave mirror of parabolical size. What is parabolical size? I told you that in the middle of it there used to be a hole, and then like that all is things are as usual normal. So in this case we'll use a concave mirror as secondary mirror, and the final image will be produced here, and observer will see by using a eyepiece lens. Now magnifying power of Cassegranian telescope when an object is at least distance of distinct vision will be very similar to the astronomical telescope. What was the magnifying power for astronomical telescope? It was m is equal to F0 by Fe into 1 plus Fe by d. This was the magnifying power when object is placed at images formed at least distance of distinct vision. So this thing will also be applicable for Cassegranian telescope. Okay, so where image is forming, if you consider that image is formed at least distance of distinct vision, then for sure this will be the magnifying power F0 Fe 1 plus Fe by d. So finally we have finished your ray optics chapter by discussing all possible topics. My suggestion is to you, please go through it. Practice hard, don't be panic, and optics is very interesting topic, and in next class we're starting with wave optics. One more thing, in my previous classes, if I have missed some word by mistake, if some term has been placed wrongly by mistake, and if I have written something wrong by mistake, my apology to you. I apologize for it. You just inform me, you just rectify the correct, you just identify that wrong part to me. I'll try to correct if possible. And for the ray optics chapters, this was the topics you should know, and in the next class we'll meet with a fresh subject topic, or fresh chapter, that is wave optics. Thank you so much.